Hello everybody and welcome back to another C++ programming exercise video, and in today's video we're going to be doing C++ programming exercise number 18. Now C++ programming exercise number 18 says the equation of a line in standard form is ax plus by, which is equal to c, wherein both a and b cannot be 0 and a, b, and c are real numbers. If b is not equal to 0, then negative a divided by b is the slope of the line. If a is equal to 0, then it is a horizontal line. And if b is equal to 0, then it is a vertical line. The slope of a vertical line is undefined. Two lines are parallel if they have the same slope or both are vertical lines. Two lines are perpendicular if either one of the slope lines is horizontal and the other is vertical, or the product of their slopes is -1. Design the class lineType to store a line. To store a line, you need to store the values of a, coefficient of x, b, coefficient of y, and c. Your class must contain the following operations. A. If a line is non-vertical, then determine its slope. B. Determine if two lines are equal. C. Determine if two lines are parallel. D. Determine if two lines are perpendicular. And E. Determine if two lines are not parallel, find the point of intersection. Okay. Anyways, let's get started with the C++ programming exercise. So already we can see that we have all of our variables that we need declared right here. And we have a couple of comments that we can use to just explain what each of these things does. So this is just the point of intersection. This is the function to determine if this line is perpendicular to other line. And these are just the necessary things that we need to have. Okay. Okay, so now we must go over to the implementation of these functions. Keep in mind, these are just simply all the stuff that the function has, that the book or the programming exercise has already defined for us. These are just the functions that the exercise has told us to do. Okay, so here we have our file implementations. These are just the header file functions inside of our implementation file. Make sure that you include CMath because we're going to be doing lots of complicated math, of course. Anyways, let's get to doing this code. So the first thing that we want to do is that by default, we want to make sure, this is going to be set line. So all we're going to do is we're going to write in x coefficient must be equal to a and y coefficient must be equal to b, because those are the variables that we're using right here. And now in this case, we want to make sure that if a and b is equal to 0, then that will mean that the constant term will also be equal to 0, because 0 will be equal to 0, of course. But since that isn't always the case, we can write in else the constant term will be equal to c. Now we have to do the function that prints out the equation. So now first we're going to print out the x coefficient with b. We're going to print out the x coefficient with x next to it, and then we're going to write in if the y coefficient is less than 0, we enter a negative value, or we enter the minus sign, else we enter a plus. The reason that we are doing this is because we must, the reason that we're doing this is because they don't automatically put a plus if something is positive, so we must have that plus there. The next thing we're going to do is we're going to return the absolute value of the y coefficient. We're going to print it out. because if it's negative, we already have the negative sign there, so we don't need double negatives. And then we're going to write in a little bit more. All we need, and then from there, all we need to do is write in y is equal to the constant term. And from there, we can see that we are done with our equation function, which prints out the equation. Now, all we need to do is return for these ones, get x coefficient. All we need to do is return the x coefficient, and for the return get y coefficient, all we need to do is return the y coefficient. And for get constant term, all we need to do is return constant term. And under set x coefficient, all we need to do is make x coefficient equal to cof. And for set y coefficient, all we need to do is make y coefficient equal to cof. And for set constant term, it's also very simple. All we need to do is write in constant term is equal to the c value right there. And for returning the slope, all we need to do is write in return negative x coefficient divided by y coefficient. Okay, so now after that, we need to go over the vertical line. So basically what we need to do is this determines whether a function is a vertical line, okay? So basically, if the x coefficient is, if the y coefficient is equal to 0, then it will, of course, be a vertical line. But, however, if it is not equal to 0, then we return false, because it's not a vertical line. For horizontal line, it's pretty much the exact same thing, except x coefficient is switched out for y coefficient. Okay? Okay, so there we go. Now, if you don't understand, this is just the formula for slope, okay? So now we need to move on to equal lines. Equal lines is basically going to determine whether a line is equal or not. Okay? So, you plug in a line into the equation. You need to plug in another line in order to see if the current class you're running this on is equal to the other line. Okay? So what you first want to do is you want to write in if the x coefficient is not equal to 0, right? Then the factor is equal to the other line dot x coefficient divided by x coefficient. This factor is what we're going to be using to determine whether a line is whether the line is equal to another line. But we also need to check that if the x coefficient is equal to 0, which can happen, then the factor needs to be the factor needs to be the other line's y coefficient divided by the current line's y coefficient. Now we need to make sure that if the x coefficient times the factor is equal to the other line's x coefficient, and the y coefficient times the factor is equal to the other line's y coefficient, and our constant term times the factor is equal to the other line's constant term, then we need to return true. If that is not true, then we need to return it as false. Because since we're having the y coefficient divided by the other y coefficient, so since we do this equation, it would dictate that if we multiply the factor by this right here, then you would get this term right here. So it's just basic math or algebra. So all we need to do is get an if statement that looks like this. And then we can just write in right here, return false. Okay. Because if this doesn't execute, this will. Okay, now we can go on to parallel lines. So now the first way that we know that two lines are parallel is if their y coefficients, and if both of their y coefficients are equal to each other. But another way to determine if they're parallel is if the x coefficient divided by the y coefficient is equal to the other line's x coefficient divided by the other line's y coefficient. So we can do something like this. And now, the way that we know that something, for sure, that two lines for sure are not parallel, is if one of the line's y coefficients is equal to 0 and the other line's y coefficient is equal to 0. And this can go for either one, meaning that that our y coefficient may be equal to 0 and the other ones might not be equal to 0, or ours might not be equal to 0 and the other one will be equal to 0. But at the end, just to make sure that we didn't miss anything out, we return false at the end, if it ever reaches that point. Excuse me. Now we can move on to perpendicular lines. So we're going to start this all off by taking a look and seeing that if both of their y coefficients are not equal to 0, then we have to enter an if statement. So now if the y coefficient is not equal to 0 and if both y coefficients are not equal to 0, and the x coefficient divided by the y coefficient times the other line's x coefficient divided by the other line's y coefficient is equal to -1, then we can return true. Else, we must return false. So we'll write something in like that. And then if this is true, then this whole thing will return true. Else, we must return false. Also, if the x coefficient of our line is equal to 0 and the other line's y coefficient is equal to 0, or the y coefficient is equal to 0 and the other line's x coefficient is equal to 0, then we also must return true. So then we'll have something like this. And if none of that returns true, then we can return false at the bottom of this function. Now we have to determine the point of intersection. So now we only have two functions left. Those two are the default constructor and the point of the intersection. Let's actually do the point of the default parameter. It's really quick. All we need to do is take advantage of just using the set line a, b, c. And that's it. We just do this. And we put a semicolon at the end, and that's it. Now we can get to doing our point of intersection, which is the last function. So the first thing we need to do is check out if two lines are equal, okay? Because since we're going to try and determine the point of intersection, we need to check if two lines are equal. Because if two lines are equal, that means that they have infinite many points of intersection, and they always are intersecting. So we need to write in if equal lines, and we plug in other line, then we must print out or see out both lines are equal, they have infinite many point intersection. Else if the lines are parallel, they will literally never meet. So else if parallel, other line, we plug another line right there. We can print out the lines do not intersect, no point intersections. Else, that means that they do intersect at some point. So we can first print out the point of intersection is, and right there we just print that out, and now we need to determine how we will calculate the point of intersection. So now in order to find the point of intersection of a line, the way that we do it is we have the constant term and then we multiply it by the other line's coefficient. And then we have our y coefficient multiplied by the other line's constant term, and we subtract each of those terms. So then we'll end up with something that looks like this. Divided by, and then we're gonna have the x coefficient times the other line's y coefficient. And we're going to have something like that. And then we're going to print out, comma, constant term times the other line's x coefficient minus x coefficient times the other line's constant term divided by, and then you're going to have something like this as well. And now, from there, we just ended off by writing in there. And that should be the end of our point of intersection. Now let's run this program and see if everything runs all right. There's obviously going to be some sort of error, of course. Check it out. Oh, and I accidentally forgot to write in the double factor up top right here. Let's run this again, and we see that everything runs just fine. Line 2x plus 3y is equal to 4. The slope of the line, 0.66666667. Line 2, 3x plus 5y, which is equal to 7. Line 3, which is 2x plus 3y is equal to -2. So we're running this little testing program in order to show how this works. So that's basically what you're seeing here. Line 1 and 2 are not parallel. The point of intersection is -1, 2. There we go. Okay. So now we can see that our program works and runs just fine the way it does. We can see that everything works all right. So these are us declaring them. These are some if statements determining, printing out some certain stuff depending on the outcome of this line. So I guess that's it for this program exercise. We're all done with it, and I'll see you guys in the next video. Bye.